Hello everybody, let's talk about the area of a trapezium. To be able to find the area of a trapezium, you need to know a key feature in a trapezium. That one thing, that one factor that enables us to identify a four-sided shape as a trapezium. And what is that one feature? What is that one key property of trapezium? Is one pair of opposite side is parallel. There's one pair of opposite side is parallel. And what does that mean? How do you find out parallel side? Parallel side is not equal. Parallel side may or may not be equal. So let's look at which two sides are parallel. I've got a trapezium over here, but we don't know yet. We're not sure if this is a parallel. This is a trapezium. So let's figure out if this shape is a trapezium. So what I'm going to do, I'm just going to extend this side, the top side, and extend this bottom side, and let's see what happens. So I'm just going to extend this top side, and that's what it's going to look like. So the red line is actually the extended side of a trapezium, and the other side I'm just going to quickly extend as well, the opposite side of it. And look at this now. These two sides, if you look at these two sides carefully, the distance between these two sides are not changing. So these lines run parallel to each other because the gap between them is not changing. Whether you extend the lines on this side or whether you extend the lines on that side, they are equal distance from each other. Their distance remains constant, and therefore we can call them parallel sides. What's happening in the case of the other two sides? Now I'm just going to look at the other two sides. Here it is, and the other bit is over here. I think I shouldn't stretch the string too much. Okay, here, let's have a look over here. Now look at this. When you extended this side, on this end, after extending the side, the width or the gap between these two lines are broadening. It's becoming more and more. Here the lines are becoming narrower, they're becoming closer to each other. Now after they come closer, they finally intersect at this point. So these lines are non-parallel lines. They are not parallel because they intersect, and here the gap between widens. The distance or the gap between these two lines do not remain constant. So these doesn't remain constant. So these lines are non-parallel lines. Now for trapezium, there has to be only one pair of parallel lines, and that's the case in this shape. There is one pair that's parallel. So we tick off that key property, and therefore we can call this a trapezium because this line, so this line or this side is parallel to this side. And if you have one pair of opposite sides parallel, it is a trapezium. Now let's go to the area. Now to be able to find out the area, step one, what do you do? Step one is you need to tick off the sum of parallel lines. Sum of parallel lines, you need to add up the parallel lines. So obviously in this shape, that's another trapezium shape, because in this shape, this line and this line are parallel. If you imagine this line being extended and this line also imagine to be extended, the gap between them is not changing. So these two lines are parallel. However, the top line is going down and the bottom line is going straight, and they might meet somewhere over here. So look at this, they're narrowing down and here they're opening. So those two lines, the top line, the bottom line, these are not parallel lines. Okay. However, these lines are parallel, and the arrow is the sign of a parallel line. So if you see an arrow, that means you're being told that these two lines are parallel. Now after identifying our parallel lines, you have to sum them up, you have to add them up to be able to find the area. So to find the area of a trapezium, step one is to identify your parallel lines, then add up those parallel lines. So 10 and 15, if we add up, it's going to give us 25. So we have added up our parallel lines. After that, you have to times the sum by height. So times it by height, by the gap between them, the gap between the parallel lines, gap between the parallel lines. So now the gap between these two parallel lines is 12. Look at this. That's the two parallel lines, and the gap between them is 12. The gap is not 13, because whenever you measure the distance between any two things, it has to be the straight distance, right? It cannot be this slant distance. So 13 is the incorrect measurement for the gap between this line and this line. 12 is the correct measurement because 12 is straight distance, right? It's 90 degrees. Sometimes if you twist this shape, it may look like this. And sometimes this gap between the two parallel lines is also called the height. All right, so it doesn't matter whether you call it a height or the gap between two lines, same thing, but you have to times the sum with the gap, which is 12. So sum was 25 and I'm going to times it by 12, and this is going to give me 250 plus 50, which is 300 centimeters square. The last bit, we have done this. Step 3 you have to half it. Whatever answer you have got in the previous step, you have to half it. And how do you half it? 300's half is 150, and that's your area. There's a step 4 where you have to use the correct unit of measurement for area, and correct unit of measurement is centimeter square, because this is centimeter length, that's centimeter length, all the lengths have been given in centimeter, so the area is going to be centimeter square. So your area is 150 centimeter square. That's your answer. Now let's put all this thing into a formula, okay, with pronumerals. What if I call this parallel line and this parallel line A and B? So let's use this notation, yeah, the pronumeral. So the pronumeral A represents first line of the pair of parallel lines. The second line is represented by B. So you have to first of all add, I'll just move this shape a little further down. So I'm just going to move it over here. Yeah, so the area will be A plus B. That's your first step, isn't it? So sum of parallel lines, the A plus B, times by height of the trapezium. But in this case, this is not the height, this is the gap between them. So you can just write a D, the distance between the parallel lines, times it by the gap between the parallel lines, which is distance. Sometimes some of the textbooks may use H. That's a height of the height of the trapezium, sorry. So don't get confused, you should know what quantity that is. So if these two lines are parallel, you need this gap between them. Sometimes it's called the height as well, okay? So D divided by 2, that's our final step, half it. So when you divide something by 2, that's halving, and that's your formula for trapezium's area, and you're done. Area is A plus B times D over 2. 3 steps, area for trapezium is done. Make sure the key property is one pair of parallel lines is parallel. That's it. And another pair of lines is not parallel, and that makes a trapezium. Thank you so much. Bye bye.